Welcome to General Chemistry Mini Lecture Series, Lecture 2, State of Matter and Phase Change. We know all matters have three common phases: solid, liquid, and gas, depending on the temperature. The three different physical states or phases of matter can be changed. For example, if we heat a solid, so it becomes liquid, and that process is called melting, or that phase change is melting. If we apply heat to liquid, it will turn to vapor or gas. That process is called vaporization. Then the reverse process, apply cooling to gas, condensation would occur. The phase change is called condensation. So gas becomes liquid. If we further cool a liquid, then the liquid will become solid. That process is called freezing process, or the phase change is called freezing. Now there are two more. If we apply heat to a solid, it will end up actually in this case gas. So this process is sublimation. As one example, dry ice. Many of you probably heard about it. So that's a solid carbon dioxide. If you place the dry ice inside of our classroom or in a lab, we will not see liquid CO2. Instead, we'll see gaseous CO2. So therefore, that process is called sublimation. And the reverse process for sublimation is called deposition, derived from gas to solid by cooling. Now let's take a look at this phase diagram, and this specifically for water. We already mentioned the three common states: solid, this entire region is the solid region. For water, of course, that would be ice, that is ice. And this region is a liquid region. And this region is gaseous region. Now take a look at this region. Is called supercritical region, or the state is a supercritical state. So that is when the temperature and the pressure is greater than the critical point. In water, the critical point is very high. So that's the so-called supercritical state. It happens to be also my research area. In my research lab, we develop ring separation methods using supercritical carbon dioxide and subcritical water. If you guys are interested in that, you can chat with me or visit my lab sometimes. But now let's go back to our general chemistry subject. So we already learned those 6 phase changes, and I want to show you guys where you can find them in this phase diagram. If we apply heat to solid or to ice melted into water, we call this melting. Then the reverse is freezing. If we heat water, you will see water vapor. This is called vaporization, from liquid to gas. The reverse process from gas to liquid is called condensation. And now sublimation and deposition, you see, bypass the liquid region. That's the 6 phase changes. But now for the phase change, whether it's melting or freezing, you see it's right along this line. On the left-hand side, that's solid state. On the right-hand side, that's liquid state. So therefore, this line is called melting line or fusion line. Then how about this line, vaporization and condensation? We simply call that vaporization line. And here for sublimation and deposition, we call that sublimation line. Okay, so there are many terminologies on this slide. So actually this is a very helpful slide. So make sure you understand everything. Now we are going to concentrate on exothermic and endothermic processes. If we look at the phase change from solid to liquid, we have to apply heat. From liquid to gas, we have to apply heat. What is heat? Heat is energy, all right? And then from solid directly to gas, we have to apply heat. These three processes are called endothermic processes. So in endothermic process, energy is added to the system. What is the system? In this case, the system is a solid, liquid, or gas, which means when ice receives energy in the heat form, it melts into water. When water is heated, again receive energy, it becomes vapor. So that's endothermic. And then when dry ice, when you pull that out of the bag, so it exposes to the room temperature, which is much higher than the dry ice where it's located. Therefore, energy is added, so it becomes gaseous CO2. So this is an endothermic process. Then the reverse process, cooling, that's called exothermic. What does it mean? It means when water freezes into ice, heat is released to the surroundings. And when vapor condenses back to water, that also releases energy in the heat form. So does this deposition process. So therefore, the endothermic process is just the reverse process of exothermic. Endothermic, heat is applied to the system. Exothermic, heat is removed or released from the system. There are also many exothermic, endothermic processes in chemical reactions, so we'll talk a lot more later on in thermochemistry in that chapter. So you will see those terminologies coming back again. Now let's take a look at the comparison of the three physical states. First, let's take a look at the shape. Solid, of course, has a fixed shape. The shape does not change. Liquid, it does not really have its own shape. It depends on the shape of the container that holds the liquid. And you understand what that means, all right? Gas is the same thing. How about the volume? Solid and liquid both have fixed volumes, but gas is not. If the same amount of gas is sealed inside a small container, then you have pretty dense gas in there. And the same amount of gas, if you seal that in a much larger container, then the gas is not that dense, it's much more diluted. So therefore, gas does not have fixed volume. Flow-wise, solid, as you know, it does not flow. Both liquid and gas do. In terms of compressibility, we know gas is the only one that is compressible. Intermolecular attractions, that's something you will learn later on again. That's the attractions between covalent compounds or molecules. For solid, that attraction or interactions is very strong. For gas, it's very weak, and liquid is somewhere in the middle. Here shows those end of chapter quizzes. Like in lecture 1, I'm going to work on the first one with you guys together, and then you will work on the rest of them. And of course, you have to work on many more additional problems similar to this from other sources to prepare yourself for future tests and quizzes. Now, quiz number 1. Which of the following processes is endothermic? We just talked about what endothermic process is. During the endothermic process, energy is added to the system, or heat is added to the system. Among the 4 choices, D is the only one that meets the definition for endothermic, because you need to apply heat to solid so that it can be melted. So the system, let's say ice, is a solid form of water that receives heat, receives energy, so that's the system, and then it becomes water. Then it gets melted. And the other A, B, C, all of those 3 processes they are all the opposite process of melting, because all of this can only occur when the system is cooled, when you decrease the temperature. I will see you guys in lecture 3.